Good morning, or good afternoon, or good evening. This is Mrs. Grazafi, and we are on 10.01 circles for geometry. So, really important formula that you guys are going to learn today, and a lot of the stuff that we'll do today, you guys will see a little bit of this also next year in Algebra 2. So, the standard form of a circle is right here. So x minus h quantity squared plus y minus k quantity squared equals r squared. So your h and your k, those stand for the center. Notice it's x minus h, but the coordinate for the center is a positive h. And this one's y minus k, and the coordinate for the center is a positive k. It's a little thick, so hard to read. And I don't know if you can see this little flashing going on here. I apologize. I don't know what that is about. And then over here is the r, that stands for your radius, and it's equal to r squared. So given this equation, identify the center and the radius. So if I want to find the center, again, this is x minus h quantity squared plus y minus k quantity squared equals r squared. Matching these up right here. Now, this one's a plus and this is a minus. So that's really like saying x minus -5 squared, and that's what's making it the plus. So really my h is a -5. So an easier way to think about this, now that you understand why that's happening, is always just take the opposite sign. So y plus 8, that means my k is going to be -8. And my radius, I'm going to take this over here and take the square root of 8, always put it into simplest radical form. Largest perfect square I can take from 8 is 4 times 2, which gives me 2 rad 2 for my radius. Let's try the next one. Given the equation, identify the center and the radius. So here again, we're going to take the opposite sign of what we see here. So our h is going to be a +4, because that's really like saying x minus -4. And then there's nothing being added or subtracted to the y, so that's just like saying y minus 0 quantity squared. So our k is just 0. If nothing's being added or subtracted, it's a 0. And then the radius, we're going to take the square root of what it said equal to, and then of course put it into simplest radical form. Largest perfect square we can take from that is 16. So our radius would be 4 rad 2. Now let's talk about if we are given the center and radius and we want to actually write out the equation. So write the equation of a circle in standard form if its diameter is 6 rad 5 centimeters and it has a center at -3,5. So again, let's write out our formula, because this is one that you guys should have memorized. So the more we write it, the more we remember it. So now I'm going to sub in this for my h and my k. So, and over here I have a diameter, but I don't want the diameter, I want the radius. How does the radius compare to the diameter? That's right, it is half. So you're going to take your diameter, which is 6 rad 5, and divide it by 2. And remember, we can combine these non-radicals together, so 6 divided by 2 is 3 rad 5. So that's going to be my r. So I'm going to put in my hk and my r. Here we go. So x minus -3 squared, so that's going to become a plus y minus 5 quantity squared equals 3 rad 5, and very, 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 very important here that you put that 3 rad 5 in parentheses before you square it. So do not write that, because that's only squaring the rad 5, not the 3. It needs to be in parentheses like that. Now let's simplify this a little bit more to make it look nice. So we'll just have one plus sign, x plus 3 quantity squared plus y minus 5 quantity squared. And then in your calculator, you could type in 3 rad 5, hit enter, and then hit your x squared key, hit enter, and that'll give you the answer. Or you could do double parentheses, or actually the newer calculators, you only need to do one set, but you'd have to do 3 rad 5 in parentheses and then squared. Or, and actually this is more of an and, I'd say do it in your head as well. So 3 squared would give you 9, and rad 5 squared would give you 5, and 9 times 5 gives us 45. So that would be your final answer in standard form. So anytime you are writing an equation for a circle, you need two things. You need the center and you need the radius. Number 4, using the graph, write an equation for the circle. So again, in order to write the equation of a circle, so again, let's write out our formula. Start to memorize this as we write it out more and more. We need two things. We need the center and we need the radius. So here they've marked the center for us. So that's going to be -4. We're going up by ones along the y-axis. So it looks like our center is -4, 1. And then I know this was not that clear, but if I had printed this out for you, I would have made it clearer where these 4 points are lattice points. So they're touching on those boxes. So anytime you have horizontal or vertical lines, we've talked a little bit before, you're allowed to count them on the grid. You don't have to do the distance formula. Now, if these were off at a diagonal, then like if you're using this point right here, then you would have to either use Pythagorean theorem or distance formula. But since this is along a horizontal line, I can count the boxes 1, 2, 3, 4, 5. So my radius is 5. And now substitute in. So this is my H, my K, and this is my R. So again, I've got H and K and my R, and that's what I'm going to be substituting into my formula. So X minus -4, so that's just going to become X plus 4 quantity squared, plus Y minus 1. Again, notice we take the opposite sign. So H was -4, so it's plus 4 in the parentheses. K is positive 1, so it's minus 1 in the parentheses. And then we're going to square 5 to get 25. And that's your equation for a circle in standard form. All right, moving right along now. We've got the next one is graphing a circle, but I didn't just give you the circle, I gave you a little system here. So a linear quadratic system, so having a circle and a line. To graph a circle, you must have two things. We just said you have to have a center and you have to have a radius. Now I said here you need graph paper and a compass. If you don't have a compass, that's fine. We're just going to sketch it out. Do the best you can. I know a lot of you borrowed some though before you left. So if you do have them, it makes it look a little nicer and it's more clear where it's passing through what points. Solve the system of equations. So what work do I need to show? Well, the same work we've always shown for a line. Either your slope and your y-intercept, write them out, or a table. For a circle, which we haven't graphed before, you need to write out your center and your radius. And that's all you need to write out. The rest is pretty straightforward to graph. So my center, I'm going to take the opposite sign with the x. That's going to be my h, so positive 2. There's nothing being added to the y, so that's a 0. My r, I take the square root of what it said equal to, since it's equal to r squared. And that gives me 4. So that's enough to write down for that. For b, equation b, we have x minus y equals -2. I need to find the slope and y-intercept or do a table. For either of those things, I need to get it equal to y. So I'm going to subtract over the x. And then divide by -1. So I get y equals x plus 2. So I'm going to do slope and y-intercept method here. So my slope is, remember this is y equals mx plus b. So my slope is a positive 1. That's in front of the x. And the b, or your y-intercept, is this number over here, so 2. So now when I graph these, I've got my x and my y-axis. It looks like I'll be fine going up by 1s on both axes. So I'm going to plot. Let's do the circle first. So let's find our center at 2, 0. And then our radius is 4. So to graph that, you're going to go from your center up 4, 1, 2, 3, 4. You're going to go down 4, 1, 2, 3, 4. You're going to go left 4, 1, 2, 3, 4. And you're going to go right 4. So now if you have a compass, open your compass, the point, put it on the center, put the pencil on one of these 4 points, and swing your compass in a full circle. If you don't, then just kind of sketch it out and I did mine dotted just because it's easier for me to draw them usually when I do it dotted to shape it, but solid's fine too, it doesn't matter. And label it with your original equation. So x minus 2 quantity squared plus y squared equals 16. I'm going to switch colors and graph my line. So I have a y-intercept of positive 2 and a slope of 1. Remember, slope is rise over run, so that's 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1. Now it's and use a ruler to connect, which I don't have right here. And it's really, really important that you show that this line extends and it cuts through the circle twice. If I do not see those 2 points of intersection between the circle and the line, you will not receive full credit. You have to clearly see those because those are your answers. And those, if you don't show it on the graph, you're solving this graphically. So it's very important that you see them where they intersect. The other thing is a lot of students on these forget to write out their answers. So really, really important to actually write what the coordinates of those 2 points are. So we have that one point at -2, 0, and the other point at 2, 4, because those are my answers. That's where, for a system of equations, we solve it, meaning we want to find where they intersect, where they're equal to each other. And they're equal to each other at these 2 points. So also on that note, you can have a circle and a line intersect twice, like we just did. You could have a circle and a line intersect once, which this is called tangent. This line is tangent to this circle. It touches it at exactly 1 point. And you could also have it so it doesn't touch the circle at all. It will never intersect the circle. So you could have 2 answers, you could have 1 answer, you could have 0 answers. And then you also eventually will get into where you have a circle and a quadratic. You could have up to 4 of those points of intersection. All right, so let's move on now to writing equations of circles. So write the equation of a circle in standard form with a center at 7, -2, and passing through the point 1, -6. So in order to write the equation of a circle, so let's just write that out. We need 2 things. We need a center and we need a radius. Well, we already have our center is 7, -2. So we know our h and our k. We still need our radius. So this time it didn't give us a radius, it just gave us a point that it passes through. So let's graph this just to see what's going on. So 1, 2, 3, 4, 5, 6, 7, -2 is my center. And then 1, 2, 3, 4, 5, 6. It passes through this point. So draw a sketch of a circle that has this as a center passing through this point. Well, it's going to have to look something like that. So this right here is going to be my radius of the circle. So this is the point 1, -6. This is the point 7, -2. So now I still need that radius. Well, how do I find it? Well, you've got a couple different options, really a few different options. But I'm going to focus on using the distance formula to find this radius. Could you use Pythagorean theorem? Sure. You could also use the formula to help you find it, but I want to do it using the distance formula. I think it's important right now to practice that distance formula and to see why we would use it. So we'll write out our distance formula, change in x's squared plus the change in our y squared, and the square root of all of that. Remember, you want to square the ones that are being subtracted because the distance always has to be positive. So now I'm going to use these 2 points to find the distance. So let's call this our x1, y1, and this one will be our x sub 2, y sub 2. So the distance, and really actually I'm going to, instead of d, because I think that could be confusing with diameter, I'm going to switch it to radius. So my x sub 2 was 1 minus 7 quantity squared, y sub 2 is -6 minus y sub 1 is -2, so that'll be +2 squared. And we're going to simplify these, so we get -6 quantity squared plus -4 quantity squared. Make sure the -6 and the -4 are both in parentheses. 36 plus 16 gives us rad 52. Now that's not in simplest radical form, but honestly, I'm actually not going to bother putting it in simplest radical form because that could cause me more mistakes here. The reason is because I know that I'm going to want to square the radius, and it's much easier to square rad 52 than it is to square 2 rad 13, because that's the one that often students mess up on and forget to square both the 2 and the rad 13. So now let's substitute in. So we've got x minus 7, our h. So that was our r. X minus 7 quantity squared plus y minus -2, so y plus 2 quantity squared, and rad 52 squared. When you square a radical, you just lose the little house. You multiply rad 52 times rad 52 would just be 52, which is why that way is a little easier. It's much easier to square that in our heads than to square 2 rad 13. Because remember, and the reason for this, if you did rad 2 times rad 2, that gives you rad 4, which is 2. Rad 3 times rad 3, that's rad 9, which is 3. So it always works out that when you multiply a radical by itself, you get whatever's underneath the radical. And that's our equation in standard form. So the next one is very similar, except it gives us even less information. It says find the equation of the circle with endpoints of the diameter A, 1, 1, and B, 5, 5. So let's just get an idea of what this looks like. 2, 3, 4, 5, 1, 2, 3, 4, 5. So those are the endpoints of our diameter. So that means this time they didn't give us the center, that the circle passes through those 2 points. And those are the diameter. So it looks like my center is going to be about here. Now, yes, I can figure this out looking at my graph, but we want this done all algebraically. So in order to write the equation of a circle, again, let's write that formula out so we get it memorized. I need 2 things. I need a center and I need a radius. I don't have either at this point. So let's start with finding the center. Well, if I know my diameter, my center is the midpoint of that diameter. So I need to find the midpoint of segment AB. So I'm going to take my midpoint formula, which is the average of my x's and the average of my y values, and I'll substitute in. So we'll call this x1, y1, x sub 2, y sub 2. So I've got 1 plus 5 over 2, and again, 1 plus 5 over 2. 6 over 2, 6 over 2. So my center is going to be 3, 3. So now I have my h and my k. Next step, I need to find the radius. Well, we know the radius is half of your diameter. So you have 2 options here. You can either find the distance between A and B, which is your diameter, and divide it by 2. And I like that way because you're using the original points, so you know you're going to get the right answer. But sometimes that's tricky at the end. The other option is we've already found our center. Now just find the distance between your center and one of your 2 points that's on the circle. That'll give you your radius. So I don't like this way as much because you don't know if your center was right, but we can verify that graphically, and mine appears to be at 3, 3. And I do like this way because it's easier simplifying it and putting it into the formula. So I'm going to do the second way with you guys. So to find the radius, I'm going to use the distance between 3, 3 and so this point, and I'm going to use this. It doesn't matter which point you use. So I'm going to use my distance formula. So we always write out your formula 1 time per problem. So if you use the distance formula more than once, you don't have to write it out again, but you should write it out 1 time for each problem that you use it. So now, again, I don't like the D there. So radius equals, and I'm going to substitute in my points. So 3 minus 1 quantity squared plus 3 minus 1 quantity squared. And that gives me 2 squared plus 2 squared. I don't need the parentheses around those 2's. You can put them, but you don't have to because they're not negatives. And 4 plus 4 is 8. So now this is a lot easier for me to square when I put it back into my formula. So now I'm going to use this formula and just substitute in. So I've got x, well, let me highlight. So I'm using the 2 highlighted pieces. So x minus 3 quantity squared, that's my h, plus y minus 3 quantity squared, that's my k, and rad 8 squared is 8. And that would be our final answer. All right, number 8 is the same idea here. So I would recommend doing here, I'd like you to pause the video, try this one on your own, and then I'm just going to give you the answer once you're done. So again, I would start by plotting your 2 points on your graph, seeing what it's going to look like, just so you get an idea. That is not required. As you get better at these, you might not need to sketch the graph. Then find your center, and you're going to need to do that using your midpoint formula. Then find your radius, and I would do that using your distance formula. Again, I would probably do it using the center point and one of those 2 points that were given, and then substitute into the standard form. Okay, so pause and then check back with me for the answer. All right, and your final answer for this one should be x plus 1 quantity squared plus y minus 5 quantity squared equals 20. And if you did not get that and you're really struggling and you're not sure what to do, please reach out to me, let me know, and we can go over that more together. Okay, and the last one we're going to do, number 9, is solving a system of equations, but we're going to do it algebraically. So this one's a little tricky. This is definitely something that you're going to see next year in Algebra 2. Whenever you have a system like this where it's not all linear equations, then we want to use substitution. So I want to take this, which is much easier to solve for x or y, and get it equal to either x or y. It doesn't matter. Actually, we already are equal to x, so I could just leave it just like that. So 4 minus y equals x. So everywhere I see an x, I'm going to put in 4 minus y into the other equation. If you had wanted to, you also could have solved for y and substituted in for y. Either way is fine. So here I'm going to take 4 minus y minus 2. And that's going to be squared plus y plus 3 quantity squared equals 25. So here I have negative y, and 4 minus 2 is 2. And now I want to FOIL these out. So if you need to, write that out 2 times and FOIL that. So we've got negative y times negative y is positive y squared minus 2y plus 4. So that's for the first one. Then for this one, we can write that out 2 times again and FOIL that out. So I've got y times y is y squared plus 3y plus 9 equals 25. Now let's combine our like terms. So I've got y squared plus y squared is going to give me 2y squared. Got negative 2y minus 2y is negative 4y, and negative 4y plus 3, so that's negative 1 plus 3, which is 2y. And then we have 4 and 9, which gives us 13. Okay, and then next we want to, since we have a y squared and a y, we want to get this equal to 0. So I'm going to subtract 25 from both sides. So anytime there's a y squared and a y, get it equal to 0 so that you can try and factor. And Now I see that I have a GCF of 2, so I'm going to factor out my 2. Or you could have even divided both sides by 2. If you wanted to divide everything by 2, the 2 will disappear. That's fine too. That actually might be a little easier for some of you. And we want to multiply to -6 and add to 1. So we're thinking either 6 and 1, 2 and 3. So 2 and 3 look like our best bet. So we want a +3. The bigger number should be positive since we want them to subtract to a +1. And here 2 is never going to equal 0, or you had divided that out, so that's not an issue. And then make sure you show that you're setting each of these equal to 0, and then solve. So I get -3 and +2 for my y's, and I'm still not done yet. So I do see that I have 2 different y's, so that tells me I'm going to have 2 different answers. So now I need to substitute in. So I need to find x at y equals 2, and I need to find x at y equals -3. So we want to use that first equation is going to be easiest to do. So the 4 minus y equals x. And we're going to sub in our 2 in for y. So 4 minus 2 is 2. So since I put in y equals 2 and I got out x equals 2, my final answer, it always goes x, y, alphabetical order, would be 2, 2. Here I'm going to sub in my -3 in for y. So 4 minus -3. So that's going to give me 7 equals x. So I subbed in a -3. I got out a 7. X always comes first. So it'd be 7 comma -3. So 2 answers. Both of these are your points of intersection. So that tells me it's a circle and that line cuts through 2 times. Okay, and those would be your final answers. So a really long problem, but altogether it's all things that you guys have done before and are able to do. Okay, and that is it for us today. I hope you guys are all staying healthy and safe and having some fun too. And I miss you guys. And that is it for now. So Pi out.